Hi everyone, Nicholas Buffy here from sunny Cyprus, and welcome to today's theory tutorial. Now this is part 8 of the ICT Applications chapter, and today we're looking at recognition systems. Now the flow of this tutorial is going to be a brief introduction about this topic of recognition systems. We're going to be looking at the different types of recognition systems that we can see over here, what they are and how they can be used. We're going to have a look at the general advantages and disadvantages of recognition systems. And then finally, we're going to have a look at past paper questions. Questions which I have developed, which you won't find in past exam papers. And these questions are designed in such a way so that you learn to answer the questions, but at the same time, you learn the content as well. As always, you can download the resources I'm using for this presentation in the description of this video, and in the description in the video below, you can also find links to the other parts of this chapter for ICT applications. Okay, so here we've got recognition systems. It says, recognition systems are technologies that automatically identify individuals or objects by analyzing unique characteristics or patterns. These systems often use biometric data such as fingerprints, iris patterns, facial features, or voice patterns to verify and identify people. Recognition systems are commonly used in security authentication and access control applications because they improve efficiency, accuracy, and safety when identifying people or items. Now, this particular chapter on recognition systems, some of the topics overlap a little bit with data entry, automated data entry methods in chapter 2. We've also got over here, you can see in red, I've got QR code readers for tickets and payments. We've already covered that when we were looking at computers in the retail industry. Again, so we're not going to be covering all of that all over again. However, recognition systems, for example, OMR, OCR, optical mark recognition, and optical character recognition. These are good for identifying either security access, exam papers. If you're looking at optical mark recognition, you're looking at OCR for identifying text. We can use this kind of identification with ANPR, which is the automated number plate recognition. We've got RFID tags, where we're going to learn about how these tags can be used to scan items or scan multiple items, do stock control, or identify or track a particular person in a building. These kind of things which are more on recognizing and identifying rather than just data entry. Then we've got biometrics like fingerprints, face, retina scanners for security. These are identifiers which are used to, or readers which are used to identify, for example, a person by reading some biometric data about that person, like their face recognition, comparing that with the database to identify who that person is. So this is more on the recognition side of things. It's not about the automated process of entering data, which is what we look at in chapter 2. So let's move on to our next slide and take our first topic. Okay, in this first slide, we're going to look at biometrics. Now, I've got for you the 4 main types of biometrics here. We've got fingerprint scanner, palm scanner, face recognition, and iris scanner or retina scan. Now, all of these are primarily used for identification of a human being and to give access to a certain area, location, application, or something like that, usually for identification purposes and for gaining access. Now, I've got for you a table over here as well, which covers the different types of biometric recognition methods, their common uses, what they're more appropriate for, advantages and disadvantages. So let's have a look at this very first one here. So the fingerprint scanner requires the user to scan their finger so that the scanner can identify the patterns on their fingerprint. It will check the pattern that it records of that fingerprint with a predefined record, a record which you have recorded in the past already. So before it can actually identify you through your fingerprints, then you have to record your fingerprints in that system first. So the process will generally be you use the scanner to record your fingerprint. The reading from your fingerprints are then stored in a database somewhere. That pattern is linked to some kind of data, for example, authentication, a password, a username and password, or just your personal record, your details. And depending on the system, the next time you use that scanner, if it identifies your fingerprint, it will check the records and give you authorized access to whatever it is you're trying to use. For example, it may be an entry system to some kind of door. It may be you to unlock your mobile phone. It could be any one of these systems. Now, the bad thing with the fingerprint scanner is that most people use their hands for different things, manual work, and sometimes it's hard for some people, especially if they do manual work, to have a proper recognition of a fingerprint. Hands may be dirty for younger people. If you use a fingerprint scanner, and I've seen them in libraries for students to sign in and sign out books easily just by using their finger, many times it may not work because their fingers may be dirty or very sweaty or whatever other reason. However, it is a cheap system, easy to implement, and it's quite fast in recognition, but sometimes can cause delays. Some people find it hard to get their finger in the right position. Normally, we would record more than one finger just in case there's something wrong with one finger. We've cut our finger and it doesn't recognize it. So we'd normally record a second or a third finger as well. Okay, I've got here for fingerprint recognition, unblocking phones, attendance systems, building access. More appropriate for personal devices, everyday security. Well, yeah, we don't need very, very high security. We do need a good amount of security. But let's say unlocking your phone, you don't really want to, touch the whole palm of your phone to read the whole palm. Face recognition is actually quite good as well and quite quick, but lighting conditions, we're going to see that a bit later on. Most people find it easier just to use a fingerprint. Some disadvantages are cuts, dirt on finger may prevent reading. Fingerprints can be copied. They're not that secure. Okay, so lower security levels. Let's look at the palm scanner. Now, the palm scanner here, we can see this particular scanner. It's not one that you actually press down on too hard to read your palm scan, but some of them you put your whole hand on and it will scan the palm of your hand. It's very similar to the fingerprint scanner, but it's much more difficult to copy or replicate because you've got more data that you're going to be reading on the palm of the hand. Again, some similar disadvantages to the fingerprint scanner, but because it's harder to replicate and it's harder to copy or somebody's palm, then the type of uses that we have for that are slightly different. Normally workplace, entry systems, employee attendance, hospital identification. Places where we're not going to unlock or need access again and again and again, many, many, many times, like a personal device. Think about how many times you lock and unlock your mobile phone or your smart device or your tablet on a daily basis. And then think about how many times you access entry to a particular building. So organizations with many users, it's a great system. It's an elevated form of security, more accurate than fingerprints. They're more difficult to fake. The equipment is more expensive. Now, when we're looking at disadvantages of something being more expensive, we need to relate it to something else as well. So we could say it's more expensive than using a fingerprint scanner. Larger scanners are required, so the footprint of the device itself is going to be larger. So that is something that you need to factor in depending on where this thing is going to be placed. Now, I'm just going to remove myself every so often from the video so that I'm not on top of the text here. Our next one is going to be face recognition. Now, face recognition, I think a lot of people use this to lock and unlock their phones. This has been used really quite well with unlocking mobile phone devices. However, if you do use face recognition, you will find that sometimes lighting can affect how accurate this is. And some people don't prefer it. Most people prefer a thumbprint, a fingerprint. Now, when it does facial recognition, what most people don't realize is it doesn't actually take the picture of the face and compare it to another picture. Well, it kind of does, but what it does, it takes measurements and all of these vectors that you can see here, right, from the tip of the nose to the corner of the eyes, to the bridge of the nose and then going around the eyes where the forehead area is. All of these things are the things it actually records when you record your face the first time. Now, face recognition is actually used quite a lot when you have to do remote authentication. What do I mean by remote authentication? If you need to authorize who you are, let's say to a bank or some other kind of government agency, then one method that is used quite oftenly is you have to take a picture of an authorized or a government issued identification card or your passport. It will first scan the passport. It will check that the passport has the correct details and the number on the passport or the number on the ID card matches that particular ID card and who it says it is with all the data. And then they will ask you to take a picture of yourself at appropriate distance, something like the picture you can see here of the gentleman here with all these measurements, a plain background, and then it will compare the picture that you're taking now from your camera using their security application with the picture that you scanned of your ID card or your passport. And then if the two match up to a certain percentage, then you're gained access and they can verify that it is actually you contacting them. So this is a really good method to verify somebody through a picture and a camera, which is scanning somebody's face or taking a picture live now. So face recognition, much more complex, a lot more data recorded there. Security is much higher when you're using face recognition. So we can see here phone unlocking, surveillance cameras, airport security. Airport security is a good one as well. If security is actually looking to find somebody, then the cameras around the airport, they can be scanning people's faces. And if they find a face which matches a picture of someone that they're looking for, something we see on in the movies quite often, this is actually a real thing. It can be done very easily. Public security and monitoring. So it's more appropriate when you've got, instead of just, let's say, single access to a mobile phone, it's more appropriate when you want to identify people or find somebody for security reasons in a public area. And instead of like humans looking for that person, they can use technology and cameras to scan many hundreds of thousands of faces very, very quickly in a public area. Contactless can identify people at a distance, okay, because if you can take a picture of someone, then that picture can be compared with a picture which is on record. And disadvantages can be affected by lighting, angle, privacy concerns, face change as people get older. So people's faces do change. If somebody is trying to avoid security somehow, then usually they will try and cover their face, wear glasses, wear a wig, pull the hoodie on so their face doesn't show very clearly. So these are ways which face recognition cannot overcome. Okay, the next one we're going to look at the iris scanner. Now, the iris scanner here, what it actually scans, it scans the veins and the patterns in our eye. So what happens is when it takes, the first time you're going to record, it's just like a fingerprint or anything else. You're going to have to scan the retina of your eye by looking into this beam or looking into the camera that it's got. And you have to be at a specific distance and it has to be a clear image. It shouldn't be blurred. And if it identifies that this is a proper image, it will record the image of your eye. And it's like a fingerprint with unique patterns, but much more complex, very, very complex. A lot more data is recorded with an iris scanner. So it's great for high-level security areas. It says here, border control, high security labs, military facilities. It's ridiculously hard to mimic somebody's eyes or the pattern in their iris. More appropriate for very high security areas. Advantages, very accurate. Iris patterns are unique and stable. They don't change. Expensive. Users may find it intrusive or uncomfortable. So the other thing is, again, with facial scans, some people are concerned about, storing their personal information or their image on different databases. Iris scanners are a little bit more intrusive because you have to get up close to the camera for it to scan the iris of your eye. And it can feel a little bit uncomfortable. But at the end of the day, iris scanners are the highest of the security, let's say, when it comes to biometrics, because the amount of data which it records is much larger. The data that on your eye, for example, the patterns you are stable. They don't really change. Unless you went out for a heavy night drinking the night before and your eyes are bloodshot red, then there may be an issue of your iris being read properly. For me, the main disadvantages of all of these systems come down to the same thing. You're relying on biometric data which humans carry around with them. It's part of their body. And that part of their body can be damaged or it could change, which renders the system of authentication useless. So you need to have a backup system. Think of your smartphone. If you scan your finger 2, 3, 4 times, your fingerprint scanner, and your phone doesn't unlock after 5 attempts, usually it will say, you've tried too many times. We can't accept a fingerprint scan now. You have to put your password. So you're resorting back to entering a password instead of using the biometric data. And when it comes to security, the weakest part of the security is the weakest link. Now, if the password is weaker than a retina scan, that basically means the retina scan, the level of security you got, comes down to just the password again. Because if you can't identify the person and you have to resort to a password afterwards, let's say a code that you're going to enter, then that's an issue. The advantage is that if it does recognize you, you don't have to enter the password. It is faster, generally faster. You don't have people shoulder surfing to see what password you're using so that they can steal access or gain access to something they're not allowed to access. So essentially, all of these biometric systems normally boil down to a backup password, which for me is the weakest link there. Okay, that's biometrics. Again, we're going to look a little bit more into biometrics with a sample question, which I have developed for you when we look at the exam questions later on in this tutorial. Okay, this next slide covers OMR, optical mark recognition, and OCR, which is optical character recognition. What are they and where would they be used? So let's take OMR first, which is on the left-hand side of our screen. So we can see here, and if you've ever done some kind of OMR test, then this is going to be quite familiar to you. OMR is where we have something like an answer sheet, and let's say multiple choice, and with a pencil, we fill in the area for the one that we think is correct. For example, A, B, C, or D. Now, the optical mark recognition, what it will do, the reader itself, which is down here, it will scan the paper in, light will shine down on the paper, and then where there's a mark with your pencil, less light is reflected. Where there is no mark, more light is reflected. So where less light is coming back, then that's the one that you selected. That's the answer. And that's why it's important when you're doing a test. If I just escape that, and you're going to fill in, you have to fill in the area, all of that area. You can't do just a little bit like that, because then if the whole circle there is not totally filled in, then you're going to get more light coming back and it will be something like indeterminate. It won't be sure. If you fill too much and you go over the area that you have to fill in like so, then again, it may not know whether you've actually filled in B or C or A. So it's very important that you fill in, whenever you're doing something like this, you fill in only the area it tells you to fill in. So how does it work? What's important about this? Before you actually start scanning all the papers through from a class, then what you would do, you would feed and you will record an answer sheet. You will record one which is already completed, and you will tell it that this is the correct answer sheet or the mark sheet. Once it's recorded that, then you pass all the other papers through, and because it knows which ones are the correct ones, it will automatically output in a file, PDF, or a spreadsheet, or on a display, and it will tell you the grade of each one. automatically and tell you what they did right and what they did wrong. What are the uses? Well, the uses may vary. One use is things like mark sheets for multiple choice questions. They're great for that because you can grade papers really quickly, hundreds of them very quickly without having to go through them one by one. I do think these are becoming a little bit more obsolete now, especially with online forms and quizzes, which actually mark and give the results to the teacher instantly. But anyway, the other uses are things like lottery tickets. They're all used quite oftenly as well. So when you're going to purchase a lottery ticket and you fill in the numbers that you want by scribbling on the ones that you want, and you get your ticket. For voting ballots, again, these have been used for voting in the past, where you would just put a mark on the person you want to vote for, and then all these ballots are recorded and counted automatically. So optical mark essentially will read a mark which is placed by the user on a unique piece of paper, so that the marks are placed in the correct place. And then with the mark sheet, once it's recorded in the reader, it can then read hundreds and hundreds or unlimited amount of papers or answer sheets and give the results for each one in comparison to the mark sheet that you recorded. Okay, OCR, optical character recognition. Now, optical character recognition is something which is really useful. Take, for example, this document scanner here. If we have a document and we want to scan the page of a document, then what this scanner essentially what it would do, it's an all-in-one kind of process. It will scan this page or this book, and then the software it has, it will identify the text. Now, if we take a picture of a book or a page, then yes, we can read the text in the picture, but we can't edit the text. And that's where OCR comes in. If you want to take that text and then be able to edit it, so you don't have to type it all over again, that's one good method that you can use, OCR. And I'm going to show you a demonstration of that right now, because you have OCR software already on your computer. If you use Windows and you use a snipping tool, the new snipping tool does actually have OCR. So let me demonstrate that to you now. So this is a PDF version of one of the books that I have for ICT. You may have this book as well. Now you can see this is in PDF. Now, if I want to be able to, let's say, for example, my English isn't that good, and I want to be able to take this text so that I can place it in some kind of translator to translate it into Greek so that I can understand it easier. Or maybe I just want to copy this text and put it in Word so that I can modify it. If I use my snipping tool in the traditional way like this, take a picture, do this, then this is just an image. And if I place this in Word, that's a picture. I can't modify this text. If I want to translate it, I can't do that. So how could I do this? Well, the snipping tool has actually provided you now, the newest version of the snipping tool has actually got OCR built into it. So when I take a new snip like so with the snipping tool, up here we've got this button here, and this is called scan text. Now if I click on this, the AI is going to identify where there's text, and you can see the white areas now. These are the areas that it has identified text. And what do I mean by that? If there was an image, for example, let's just take a different scan. Let's scan something which has an image in as well, like this. There you go. So it will identify, if I click on scan text, the white areas are the areas which it's identified text. The OCR is identified. The image is ignored. Okay. So if we just go back to the other one, which I had, since we've started with iris recognition, let's just do a quick scan, new. There's my text. I'm going to scan that text, and then I've got the option copy all text. Now, if I copy that text now, I can go to Word. I can just paste that in, and you can see this is formatting. You can format it, no problem. You can edit it. You can change it any way you want. If I open, for example, ChatGPT and I say, translate to Greek, and then paste my text, it can now translate that text for me in Greek, if this is my first language, and that'll be just so much easier for me now to understand. So there's a nice little tip for you guys. If you are finding it difficult to understand, let's say, the English text in textbooks, if you've got a PDF version, or even if you just take a picture, just load them in your computer. You can use OCR on your mobile phone. You can use OCR on images, anything that you can take a snapshot of using a computer or a mobile phone. You can now copy the text and you can place that in a translating tool, AI translating tool, in a language of your preference. So that's an example of what OCR is. Okay, back to our slide. We've got other types of OCR, which are things like handheld OCR readers, where you've got a handheld device and you can just scan selections of text and it will basically convert the image that it sees into text and store it on the device. You could probably plug this in using a USB cable to then download the text that you've actually copied, and it will be in editable form. Another one that we have is your OCR on your smartphone. Now, smartphones, again, fantastic tool. These are like pocket computers. The processing power on our smartphones is absolutely immense. If you think about the processing power required to put the first spaceship on the moon, to land it, the amount of processing power you've got in your mobile phones is hundreds, if not thousands, more powerful, more times more powerful than that computer. So you can have OCR recognition software on your phones. You can also have automated translators on your phone. So these are great if you're going to go to another country and you don't know the language and there's text in another language. You can open up the translator app, just place your translator app using the camera over the text you can't understand, and it will then overlay over that text the language that you want. For example, I can overlay on, I do this a lot. I used to have a Japanese model car, and the screen or the radio was all in Japanese. I didn't know how to configure it. So I will put a Japanese to English translator on my phone, and it was live. As I had my camera in front of the screen of my radio and it had Japanese on the screen, on my phone, it would actually show it in English, and I can then configure my stereo very easily and program the channels. So we've got OCR on smartphones. And now one big use of OCR is automated number plate recognition. Now, if you've been to any kind of automated car parks, for example, as you drive in, there's a little camera and it will read your number plate. It doesn't just take a picture of the number plate. If your number plate is dirty and it can't read it, then it's not going to work. It's not going to record it. Now, if it's able to see the number plate clearly, it will identify where the number plate is on your vehicle. It will then take a picture and it will run OCR software. And for each letter, it will use a pattern like what we can see here to identify which is the number represented by each pattern or the letter. And then it will generate your license plate number. And then that license plate number will be recorded in a database so that when you're driving out of the car park area in, say, 3-4 hours from now, as you drive out, it will see your number plate, and then it will know what time you drove in, how long you were there for, and it will know how much to charge you for the parking. If we think of security, if we're looking for a stolen vehicle, let's say the police is looking for stolen vehicles, then cameras around the city, they can be scanning all the different license plates of all the vehicles. And when that vehicle is identified, it will be flagged in the police database, and they will know exactly where that vehicle was. Okay, so these are great for recognizing and identifying vehicles. And again, ANPR, I think, is a question which has come up quite often, what you can use it for or how it works. These are two different types of questions. So that's OMR and OCR, various uses. A nice little tip there for you as well to help you with your studying as well by using the translator, OCR, and the translator to translate into your own language if you prefer. Let's move on to the next slide. Okay, in the next couple of slides, we're going to be looking at RFID, or radio frequency identification. I do think that this is a hot topic for exam questions when it comes to recognition systems, mainly because of the very, very wide range of uses that we can use RFID tags. But the good thing is, once you understand and you learn how they work, then irrespective of the type of question they ask you, you will be able to answer it without having to do any revision, because once you've learnt it and understood how it works, it's learnt knowledge and you'll be able to answer any question. So let's have a look at what I've got here for you. On this side over here, in the white area, let's say, we can see where different areas where we can find RFID tags. On the other side over there in the grey section, we can see the different types of readers. Now, what we're going to do, we're going to have a look at the different types of readers, how they can be used in different areas, and the different types of tags we've got. And the first one we're going to look at here is going to be the tag. Okay, so the tags will come in different forms, but the idea is exactly the same. It's either a sticker-based RFID tag, or it could be a physical tag in a plastic keyring type. It could be a card, so this antenna and the chip is embedded inside a plastic card. So these things are really, really, really thin. And that basically means they can be a sticker, they can be a plastic tag, they can be in a credit card, they can be anywhere. So how do they work? Now, we're going to look at what the difference between passive and active tags in the next slide. But for the syllabus, the only ones you're going to be really asked questions on is going to be on a passive tag. So how does a passive tag work? In short, there's no battery. Okay, this thing has 0 battery. It's got a little microchip and an antenna. These lines going around the outside is the antenna. And what happens is when we place the tag near the reader itself is broadcasting a radio frequency. That radio frequency, when it comes close enough to an RFID tag, the antenna in the RFID tag will be energized, producing some power, and that energizes the chip in the RFID tag to start transmitting. Now, usually the transmission is one way, and it will transmit whatever has been stored on its little microchip, usually just some kind of serial number or identification number. But there can be more stored on there, things like personal details. We'll see that in a second. It starts transmitting what it has on it when it's close enough to the reader or to the antenna of the reader, which is broadcasting a radio frequency. Once it starts broadcasting, the antenna will then send the information it's receiving from the ID tag to a reader. And then what is done with that data? It depends on the system. It could be used just to identify you as who you are. It will be your identification number, and it will pop up on the screen showing your picture, your personal details, and this, that, and the other. If we have a look now, go back. So we've got, for example, RFID tags in passports. If you check your passport and you see this little symbol here on your passport, it means that your passport is equipped with an RFID tag. So as you go through passport control at the airport, you place your passport on an RFID reader. Close to it, the radio frequency from the RFID reader will energize the chip. Your chip starts transmitting the information. What information? Facial recognition information, your fingerprint. It will give your passport number. So what happens is you place your passport there. As you've got your passport there, it will scan your face and it will check if the information it's read from the facial recognition is the same as the data which is on the RFID of the passport. If that matches, you're free to go. If it doesn't match, then it will probably start going ding, 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 an alarm going off or something like that to ask for somebody to come see you and assist you. It may be that the RFID chip has been damaged and it can't read it. So then you'll have to give your passport to a physical person at passport control. They will check your passport, your picture and everything and make sure it's you. RFID stickers on vehicles. Now you can see this is a very thin, translucent sticker. It's been placed on the headlights of the vehicle. You can see these little square things here. That's the antenna and the chip in the middle. These are great in car manufacturing production. If you remember when we did the tutorial on robotics in industry, and we saw, let's say, a car manufacturing plant, well, we said that as a car goes through the manufacturing process, how does the robot know exactly what color to paint it, what kind of doors, what kind of engine, what parts it's going to need to build the car? Well, that information is transmitted, for example, when the vehicle goes through the RFID chip on the vehicle, will send the information to the reader. It will read the model number and the information about this vehicle, and then from the database, it knows exactly what is needed. Another method is to track vehicles. If you want to track where vehicles are on a very large plant, where let's say you've got trucks or vans and they're moving items in a warehouse from one place to another, and you just want to know where in the warehouse the vehicle is right now, by having RFID chips on the vehicles, you're able to track and see live where that vehicle is straight away. We're going to have to look at some more examples in a second. So these are the RFID chips, some examples of the different types of RFID that we've got and where they're found. Let's have a look at the readers. So over here, we've got a fixed reader. Normally we find things like this in, let's say, hotel rooms or access to doors or entry systems, where you are given a plastic card, and inside the plastic card, it's got embedded an RFID chip with its antenna. When you place it close to the RFID reader on the lock, this lock is actually transmitting a small radio wave, so the RFID has to be quite close to it. It energizes the card, sends the information, and if this is the number on this RFID chip is the number related to this room for this lock, then it will unlock automatically. If this is the key card for a different room, it won't work. Okay, so you can see all of these things, really, it's exactly the same method. We've got things like handheld readers. These are great for warehouses. So if we've got large stock of items and we just want to catalog items quickly and just read their information, instead of using things like barcode scanners, which you have to get up close and scan the barcode and make sure you're scanning the right one after the other, these RFID handheld readers are much easier because you can scan them from a distance. Usually passive ones from about, I don't know, 10 up to 10 meters, somewhere around there, 10 to 30 meters probably, depending on the type of chip and how good the reader is. So you can scan items quickly. Another great thing is if you're looking for something, instead of going to each item and scanning one by one until you find it, you've got a whole lot of items there. You can use this scanner, just go beep, 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 and just scan through until you find the item that you want. It's much faster. Some of these handheld readers can actually scan multiple items at the same time. So unlike barcode, where you have to just scan one barcode at a time, RFID readers can also scan, if they're using slightly different technology, but still RFID, they can scan and identify multiple items at the same time. And that's what we've got here, multiple item scanner. So here we've got the RFID reader, and here we've got different tags in different locations. Here, by scanning with the RFID reader, it could be a handheld reader or a fixed reader somewhere located in the warehouse somewhere, and it will scan all of these items. Now, this is also great if you've got a large warehouse or let's say a hospital and you want to know where doctors are. Here's a great idea. Doctors have their badge, their doctor's badge with their details and the name on here. And if that is also an RFID tag, as they're walking around the hospital, if there are RFID readers in different locations, then you would know exactly where that doctor is at any point in time when they're on hospital grounds. So as they move around and they go to a next RFID reader in a different location, you know that the doctor is in that particular location. So that's great for tagging and tracking, whether it's people, vehicles, or any scenario like that. Here we've got what we call an RFID portal. These are great, for example, in big warehouses or when trucks pull up and they're going to offload all the items that they've got on the truck into the storage area of the warehouse, and they're on pallets. These pallets have got multiple items on there. As the pallets go through this RFID portal, The RFID portal scans and logs every single device which is on this pallet without having to open the pallet, take each item out and scanning them one by one. So just by moving something through an RFID portal, multiple items can be scanned and logged. Another way is it can be a sign-in, sign-out system. Let's take again a hospital. When the doctor walks into the hospital, when he starts his shift, then as he walks through the portal, his RFID badge is automatically scanned and registered that he's on hospital premises. As he exits, through the portal, it's registered that he has exited. The hospital staff know that the doctor has left the building or left the hospital. So how you use these is unlimited ways. The way that everything works, however, is exactly the same. RFID chip, somewhere, somehow, does not have a power source, has to be close to the reader. When it gets close to the reader, the radio frequency from the reader energizes the RFID chip because the antenna on the RFID chip will pick up that radio signal. And the RFID will start transmitting short distance, the data it has. That data is then received by the antenna of the reader, and the reader will take that information and compare it to whatever it is comparing. It could be an inventory database. It could be a sign-in, sign-out. It could be recording inventory as it goes through a portal. It could be just registering that somebody has gone past a particular checkpoint in the hospital so we can track people. But the way that it works is exactly the same. Okay, so if we have a look at this next slide, it basically has here how RFID tags work. So let's have a look at this. So the RFID, not very clear, this text. Let's just zoom out a bit. The RFID is attached to assets to transmit stored data to the antenna. The asset will be the product, the vehicle, the passport, the human being's name tag. The antenna this antenna receives the stored data from the tag and transmit that data to the RFID reader. Now here you would have this antenna is transmitting a radio frequency which energizes the RFID tag and sends the data to the antenna of the reader. The type of reader that you have, whether it's a handheld, whether it's a fixed device on a door, whether it's one which is in a warehouse and scanning multiple items or in a hospital, will then take that information, connect it to the antenna wirelessly and receives data from the RFID tag. So it will get this information from the RFID tag to the reader. The reader will then send it to a computer database. Everything is linked to a database somehow into the RFID database where it can be stored and evaluated. Maybe you're tracking something. Maybe it's a car park and it's registering what time the car came into the car park, when it left, so they can charge them. Maybe it's to identify or track a doctor in a hospital. Maybe it's to take inventory of stock and record things. Maybe it's you're trying to find an item inside your stock which has been misplaced. Okay, now over here I've just got a short thing about passive and active RFID. You don't really have anything in the syllabus which has any extra information about active RFID, but you do have to know about active RFID and what it is. So passive RFID essentially does not have a battery. It gets its power from radio waves sent by the reader. It has a short reading range of 1 to 10 meters, are cheaper to produce, are commonly used for stock control, library books, and retail items. Active RFID, the difference is it contains a battery. It has its own power source. It doesn't get powered by the radio waves from the RFID reader. It's constantly transmitting its data because it has its power source. Now, the amount of power it requires is very, very, very minimal. So these batteries will last for a very long time. You don't need to know about that. What you just need to know is that active RFID contains its own power source in the form of a battery. It can transmit signals on its own. It doesn't need to be energized because it has its own power source, and it has a much larger reading range, a much longer reading range, up to 100+ meters. Okay. They're more expensive and used for things like vehicle tracking, asset tracking, and large site monitoring. So if you're tracking people around a building, instead of having multiple RFID readers in the building, if it's a large space area, you can just have one. And then, for example, doctors will have an active RFID badge, which basically is an active RFID tag or something which has its own battery. And as they're walking around, because they're transmitting their signal, you can actually track where somebody is a lot easier. Okay, let's have a look at the general advantages and disadvantages of recognition systems. Now, these advantages and disadvantages are not specific to an item like RFID, biometrics, or OMR, OCR. It's the general concept of advantages and disadvantages, and can probably be implemented in almost any kind of advantage, disadvantage question. So advantages: fast, accurate identification. Yep, whether it's OMR, OCR, it's much faster. It's way more accurate than a human being recording data or identifying people. Enhanced security. Again, it's the device itself. Let's say you're doing facial recognition for security entrance to or access to a certain system. Instead of having a human being, which is comparing a photo of you and you in person, which is much slower and can be fooled a little bit more easily. Using facial recognition has much higher security. And depending on what it is that we want to secure, we would choose the appropriate device, which has either elevated security, but normally comes at a higher cost. So that's where you will analyze the question. Automated data collection. Yeah. If you've got, let's say, a warehouse of items, instead of going one by one and tagging things or reading things with a barcode reader, you can use things, for example, RFID, and just scan very quickly all the items, and all these chips will be automatically energized and transmit their information, so you can do stock control very quickly. I do give the example to my students as well. Would it be fantastic if all items in the supermarket had an RFID chip? And then when you go to the checkout, instead of scanning each item one by one, you just push your cart through the portal, like we discussed. It will identify all the items in your trolley, giving you the total straight away of how much you owe. You simply tap the card, you pay at the EFT POS, and you're on your way. You don't have to take things out of your trolley, then put them back in your trolley in the bags so you can scan them. Okay. Now, there are some ways that some people will try to trick the system, but in theory, it's a great idea. Reduced human error. Again, if you're scanning things manually or writing things manually or one by one, then there is a factor of human error there. If you have, for example, 1,000 items to log, then it's going to take a long time. But if you use something like RFID, it's going to be much, much faster and way more accurate. Contactless operation. You don't have to be there. You don't have to physically take something and scan it if you're using RFID. Disadvantage is high implementation costs. The more secure we want something, or the more accurate we want something, then usually the costs are going to be higher. Privacy concerns. Well, whenever we're talking about systems which are storing data about people or their personal possessions, things like their face, their biometrics, fingerprints, retina scans, this is always a concern of the subject that comes up regarding privacy concerns. Can be fooled or hacked. So yeah, nothing is 100% foolproof. Anything which has been engineered by man can be reverse engineered by man. So it can be hacked. I mean, think about RFID chips. They will start transmitting data when they are energized by an RFID. Now, but the RFID, the passive ones, they have to be close to the reader. So how would you get the information? Well, if you've got a powerful radio frequency transmitter and you're sitting in a shopping mall, you're going to get hundreds of these little RFID chips on credit cards, on other identification cards, starting to transmit. But the transmission power they have is very small, so you won't be able to read it unless you have a large antenna or a powerful antenna, which is going to be able to pick up those microscopic little signals from the different RFID chips. And that way, a hacker can start scanning everybody's RFID chips which are on their possession, whether it's a credit cards, identification cards, or anything like that. Requires specialized equipment. If the equipment doesn't work, if you're scanning things with RFID or you've got facial recognition or something like that, then you're relying on technology. And when you're relying on technology, when technology fails, then the system fails. And technology costs money. Specialized equipment especially costs a lot more. So setup costs are going to be much higher. May not work with damaged items. When things do get damaged, whether it's the hardware or the actual device that you're trying to identify is not going to work. Think about ANPR, automated number plate recognition. If the number plates are broken, if they're damaged in any way or they're dirty, again, it's not going to work. Okay, we're going to start looking at past paper questions now. I've only got one, I think, which is an actual exam-based past paper question. You've got access to past papers. You've got the mark sheet. There's no point in me answering the mark sheets for you. But I have picked one which I thought is quite kind of popular and could be used. And then I've got quite a few for you which cover all the topics that we have discussed. These questions are designed not just as questions. They're designed as long answer-based questions, 6 or 8 mark questions. And the idea is that with these questions and the model answers I've given you, you're not only learning to answer the questions, but at the same time, you're understanding the topic itself. So let's get started with the first one. Okay, so this is an exam-based past paper question. It says here, Johan is going on holiday to a different country. He will need to take his passport. He has a new type of passport which has an RFID chip in it. He will be passing through automated passport control gates. Describe how RFID will be used as he passes through passport control. This is only a 3-mark question, so you're not looking for many marks here, not looking for many items. But again, remember I said RFID, the concept is always the same. The passport has got information about Johan on there. He will have to put his passport on the RFID reader. The RFID reader will energize the device and read the information. Then it will scan some information about Johan himself, for example, face recognition, maybe a fingerprint, and it will compare the information it gets from the camera of scanning him with the information on the RFID chip on his passport. And if they match, he's good to go. So the mark sheet itself says he places his passport against the RFID reader. He stands in front of a scanner, fingerprint, face, etc. His facial characteristics or fingerprints are compared with those stored on the RFID chip. So it's not what we need to identify here is here where it says describe how RFID will be used. It doesn't say how RFID works or how they will get the information from the RFID chip, just how it's used. And this is the important thing of this question. And I say it again and again and again. Read the question carefully, identify how you have to answer and what you have to answer. And here the what is how the RFID is used as he passes through passport control. So, it's got nothing to do with the technology of RFID itself. Okay, question number 2. Now, this is a question which I have put together. As I said, this is a question which covers, if you understand this question and the answer, you've covered nearly everything that you need to know when you're comparing things like RFID technology and barcodes. So the question says, a school is purchasing a large number of laptops and tablets. The school wants to track, record, and manage these devices in its inventory system. So here the keywords here is we're going to need to track devices, but also record and manage them. The school is considering using either barcodes or RFID technology. Discuss, not bullet points, discuss the advantages and disadvantages of using barcodes compared to RFID for tracking and managing the school's devices. So here we want, this is a discussion kind of question, and we want to identify things on tracking and managing the school's devices. So here's my model answer for you. But before we get to that, let's understand what we mean by tracking. If we're going to be giving devices out to students, or we're going to have a lot of devices in the school, we need to be able to have an inventory. That inventory must have all the serial numbers of all the devices. We need to record those somewhere. If we find the device and we scan it, either by a barcode or an RFID, we get its serial number or its unique number. It will compare it in the database and give us the information, who it belongs to, when it was bought, and all sorts of other information. But at the same time, if a device has been reported stolen or lost, and we don't know where it is, and we want to try and track it in the school, then we need to be able to find ways that if it appears in the school somewhere, we can find it easily and quickly. So that's the understanding. That's what you need to do before your answer. So here's my answer. The school could use barcodes to label each laptop and tablet. Barcodes are cheap to produce and implement, which makes them cost effective for the school. They are easy to print and simple to use with a scanner. Yeah, you can generate your own barcodes. If you have a look at the tutorial on computers in the retail industry, I actually gave a demonstration where I used my own barcode scanner and generated some barcodes and showed you exactly how it works. But you can generate your own barcodes. You can print them on labels and just stick them on things. Very easy, very cheap. You don't need to order them. They're nothing specialized, and they're very, very quick to read. If you've got a barcode reader or even your mobile phone, you can just go beep, 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 and scan 100 items within a minute, a couple of minutes. Easy, okay? Each device must be scanned individually. Now, here's where we're getting the extra marks. We are showing understanding that with barcode, you can't scan more than one item at a time. It's one item at a time, which can be time consuming when managing many devices. Barcodes can also become damaged or dirty, making them unreadable. That's another issue. So just from wear and tear, putting devices in bags or putting them on the desks or grubby hands, the barcode itself could be destroyed, it could be scratched, it could fade away. So then when you do try to scan it, it doesn't work. Now, you can actually print another barcode and stick it on top, but you have to know which device it is and which is the correct barcode, which you can't read right now. So it's not as good. Alternatively, the school could use RFID tags. RFID does not require line of sight, so we don't have to scan them one by one or be directly in the place on top of the device to scan it. So devices do not need to be directly visible to the reader. This makes the system faster and more efficient, especially if many devices need to be scanned at once. Now, if I've got a large stock of devices and I want to scan all of them, instead of me having to go to where all the devices are starting to go beep, 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 one by one, then I can, from a distance, simply use a handheld device or a fixed device and just scan all of them at the same time. Really easy. It could also, here's another idea, as something is taken out of the stock room, if it goes through an RFID portal, then automatically it registers that that item has been released from the stock. It's been removed from my stock. If an item comes back in to my stock after I've lent it to somebody, then it will check it that it's come back. I don't need to do it. It's a nice idea. There's just another answer for you. So then it says, this makes the system faster and more efficient, especially if many devices need to be scanned at once. Some RFID systems can read multiple tags simultaneously, which improves tracking in large inventories. Now, here is where we're comparing again to barcode. We're showing an understanding that RFID can read many devices simultaneously, whereas barcode can only read one. RFID can also help with automatic tracking. For example, if devices pass through an RFID reader at a door. Oh, look, I forgot I actually put that. I was really impressed with my understanding that I can actually check things in and check them out as you go through a door. So yeah, as devices go through the door or come back through the door when you're lending items or when they're being returned, they can be scanned and registered automatically. Just like a car with the automatic number plate recognition in the car park when they go out and when they come in, or when they come in and when they go out. However, RFID systems are more expensive to install and the tags cost more than barcodes. Yeah, these are little stickers or whatever device it is. It's got an antenna, it's got a little microchip. It's going to cost more than just printing a barcode on a piece of paper. So this question here covers, a lot about how RFID can be used in a system like this. And at the same time, we're also comparing and contrasting to barcodes as well. So a great question with a great answer there for you. Okay, here we've got another RFID tag question. Now, you're probably going to say, Why so many on RFID? I do have on other items as well, so we've got a few more questions, but it's so varied, the range of the uses of RFID tags, that students, when they read something which is totally different, they get flustered. So I want to give you a whole different range of uses so you can understand that the method is exactly the same. It's just the scenario that changes. So here it says a farmer has purchased a computerized feeding system for her goats. The goats have a passive RFID tag on their ear. What does passive mean? That's going to be a mark there. Passive means that it doesn't have its own power source. It has to be close to the reader within 1 or 10 meters so that it is energized from the reader. Describe how the RFID tag can be activated and how the goat is recognized so that it receives the correct feed and correct amount of feed. So here we're looking at a farmer. They've got goats. From the question, I can understand that different goats need a different type of feed and a different amount of feed, whether they're elderly goats, younger goats, female goats, pregnant goats, baby goats. It depends on what kind of goat it is. Okay, so just like humans and babies have a different diet than adults, same with goats. So how would that work? Well, let's take straight away our understanding of passive RFID. The goat has a passive RFID on its ear. When it goes to the feeding station, somewhere around there, there's going to be an RFID reader. When it goes into range, and this is important because only the goat which is right next to the feeder, which is right next to the RFID reader, is it going to identify that goat. So it can't misidentify a goat which is standing 2 meters away and give that goat the wrong feed. They have to be close. This is why it has to be a passive RFID. It will then read the information. It will energize the RFID tag. The RFID tag will give a serial number or some kind of number which represents the goat. The RFID reader will send that to the reader. The computer database will be checked, identify which goat it is, what kind of feed it needs, how much feed, and then it will send a signal for the feeder to place in the feeding area for that goat the right amount and the right feed. That's it. So the process is exactly the same. Here's my answer. When a goat approaches the feeding station, the passive RFID tag on the goat's ear is activated by the radio signal emitted from the reader. The tag uses the energy from the reader to transmit its unique identification number back to the reader. The reader sends this ID to the computer system controlling the feeding station. The computer then checks the ID against a database of goats to identify which goat it is and determines the correct type and amount of feed for that animal. Finally, the feeding station dispenses the correct feed and quantity, ensuring that each goat receives the appropriate feed. It may be that some goats need some medicine as well. And in their feed, it will also add the medicine. If this was, let's say, a modified question, it could be for medicine as well. So it will put the right amount of medicine if they need some medicine for whatever reason in their feed. Okay, this question here is a company wants to collect customer feedback automatically using paper forms, but is unsure whether the responses should be in the form of shaded boxes, written text, or both. Explain the differences between OMR and OCR and compare their advantages and limitations so the company can decide the best method for collecting the responses. Now, here we're looking at one or the other or both. It says that they want to collect the responses on paper. Now you say, why use paper? Why not just do it electronically? It could be they want to get responses, let's say, from delivery drivers. They don't use computers. They're always on the road. Truck drivers. They will take the form, fill it in, and then when they go back to collect another load, they'll just drop the form off. It could be they want to get information, in this case, with their customers, and their customers don't want or can't be bothered to go and sign into an application or use a link and this, that, the other. They may just prefer just to fill something in at the counter and just submit it. So in this case, it is to do with customers, and that could be the reason. That's not the question, though. The question is, what is the best way of collecting these responses? So, and you have to compare both OCR with OMR. So here's my answer for you. well, before my answer, what is OMR? OMR is optical mark recognition, and that's where we use shaded boxes. The answers that you give are fixed. You can't modify them. So the question and the answer is going to be fixed. They will give them a question. They will choose from A, B, C, D, something like a mark sheet. OCR is when we have text, and that will be the customer actually writing a response, and that text will then be identified. Now, the good thing with OCR is going to be that the customer can give a response which is not included in, let's say, the fixed response OMR questions, and they can get a deeper understanding. With OMR, though, because questions are fixed, you can do an analysis of data much easier, whereas with varied responses in text, you can't collect or organize that data in a way where you can produce charts or do an analysis. This is also something that you could use in the chapter, I think chapter 7 for the system lifecycle. So this is another one of collecting or getting feedback from people in a particular system. So that could be a modified question, or this could be a question which incorporates both the system lifecycle and recognition systems. Okay, so here's my answer for you. OMR, optical mark recognition, is used to read shaded boxes, so it is good for collecting answers like ratings or multiple choice questions. It is very fast and accurate for lots of forms, but it cannot read written text. OCR, optical character recognition, can read printed or handwritten text, so it can collect detailed written feedback. It is slower than OMR, can make mistakes if the writing is not clear, and may need checking. Especially if it's my handwriting. Remember, I'm dyslexic. There ain't no OCR that's going to recognize my handwriting. If the company only wants simple ratings, OMR is best. If they want detailed comments, OCR is needed. Using both methods together can collect both types of answers, but it takes more time and effort to process. Personally, I would say go with both. Why? You have the fixed answers which you can use for a quick analysis of results, let's say customer satisfaction, ratings, if they shop there often, these kind of answers, multiple choice, you can collect and you can do an analysis of data very quickly. Then have your text-based answers as well, which will be with OCR. These could be, do you have any other comments that you want to share with us? Now, if somebody writes clearly and the OCR is able to read it and you get that extra data, fine. If somebody's handwriting is bad and it can't read the data, well, at least you've got some data from other people instead of no data. So I will generally say both, but then again, it will depend on how much the company wants to spend, how much time they're going to be spending on collecting this data, and how important this data is to them. But that's your answer, and that is an answer which will help you understand both OMR and OCR, their advantages, disadvantages, and uses. This question is about ANPR, or Automated Number Plate Recognition. It says here, a city council has installed cameras on the roads to monitor traffic and enforce parking regulations. The system uses ANPR, or Automatic Number Plate Recognition, to read vehicle number plates automatically. Explain, there's a highlighted word, how ANPR works. So here we need to explain how ANPR actually works and describe its advantages and limitations in this scenario. So before reading the question, we've said that ANPR is a form of OCR. Somehow the cameras will be taking images or recording traffic, probably even in real time. So as it sees a camera with video, it will automatically identify the number plate and then use OCR to identify the actual numbers and letters of the number plate and record those in the database or check the number plate in a database system. Now, this is to do with parking regulations. So if it's to do with parking regulations, it will identify the vehicles as they're driving around, check their number plates, identify them in the database, and see if they have paid for parking or not. That's essentially your scenario. Now, here's my answer for you. ANPR uses cameras to take pictures of vehicles as they pass. The system detects the number plate in the image and uses software to read the letters and numbers automatically. You could say here, where it says uses software, you could say uses OCR software, and that will show a deeper understanding on your behalf. For example, to find out if it has paid parking or is on a watch list. It may be a vehicle which has in previous numerous times parked without paying, if there's an online kind of payment system, and that vehicle is on the lookout. So if they do actually see that vehicle again, it will flag it in the database and it will automatically send a signal saying that this vehicle has been identified, it's been located, and they can go find it, clamp it, whatever they're going to do. The advantages of ANPR are that it works automatically without a person having to check plates. It is fast and it can record many vehicles accurately. However, it can be expensive to install, may make mistakes if the plate is dirty or damaged, and there are privacy concerns because it records information about vehicles and drivers. Again, everything that we discussed before. The advantages are it's automatic, less human error, but there are disadvantages if the number plate is cracked, broken, or dirty, so it's not easily readable. But overall, very quick, very easy, and accurate. Okay, so that's on ANPR. And we said if you do actually expand on that and just say instead of just software, you use OCR, you'll probably get another mark, or you show an understanding that what it's actually doing is using optical character recognition for the number plate recognition. Okay, this question is focused on what we described about biometric systems, and we've got this hospital scenario here. It says a hospital wants to control access to medicine storage rooms and is considering using biometric systems to ensure only authorized staff can enter. Compare different biometric systems, describe their advantages and disadvantages, and explain which system would be most suitable in this scenario and why. All right, so it's a hospital. They've got some kind of medical storage room. Inside that storage room, I'm going to understand there's a lot of types of medicine or drugs in there which are not readily available to the public. So this is a secure area. So we need an elevated form of security, which is why they're using biometric. Now, if we're using biometric, we've said that we've got things like fingerprint, palm print, face recognition, or retina scan. Which one is best to use? Now, the scenario or the placement is a hospital. So just by understanding a little bit about the location where they are and not just answering what you know, think about it. In a hospital, think of a doctor. Right now, imagine a doctor in your brain. What is the image of a doctor that you have? Just give yourself a second. And when you think of a doctor, what picture comes to mind? Straight away for me, someone dressed in white, probably wearing a mask and gloves. So I think you understand where I'm going with this. Let's read my answers here and then we can discuss it a bit more. Different biometric systems use unique physical features to identify people. Fingerprint scanners read fingerprints and are fast, secure, and easy to use. But they may not work if staff are wearing gloves or have dirty fingers. Dirty fingers in a hospital, not so much, but a valid point. Could be covered in blood. Ew. But most doctors are always wearing gloves. So that would mean they would literally have to take their gloves off to scan. And those gloves normally have some kind of powder or their hands are sweaty, so dry. So fingerprint scanner, although cheap, easy, a lower form of security than the rest, not very practical. Facial recognition scans the face without contact, but masks, poor lighting, or changes in appearance can cause errors. Iris scanners read the patterns in the eye. They are contactless and hygienic, but they are more expensive and may take slightly longer to set up. Something we didn't mention about fingerprint scanners as well. You're in a hospital, probably germs, diseases. You don't really want to be able to scan with something you make contact with. Literally, different people touching the same thing, because then you're going to have to use antiseptic all the time. So that's another reason why fingerprint scanners are not so good for me. Facial scanners, again, you've got the problem with a mask. You might have to take the mask off, put it back on again. Somebody may be on long shifts and, hasn't shaved in a while, and probably not a good idea, but the facial recognition may not work properly. And then you've got iris scanners as well, which are slightly more complicated, a lot more secure. The advantages of biometric systems are that they are very secure, difficult to fake, and staff do not need to carry keys or access cards. There you go. Don't need keys, don't need access cards. Everything they need to access that room is on their body. It's physically their body. So if they need access to medicine quickly and they've forgotten their card, it won't be an issue. They can also log who enters, helping with accountability. The disadvantages are cost, potential errors if the system cannot read the feature correctly, and privacy concerns because personal biometric data is stored. Now, again, whenever we use something to do with biometric or recording somebody's personal belongings or themselves, we've got things like personal data being stored and issues like that. However, when we do use systems like this instead of a key, and we use a system where we're using biometrics, then it will also log who accessed last, when they accessed, and it will keep this log. So if something does go missing, you know who literally had access to that storage room. And it's not like a key where somebody can take the key, use the access the room, take things, and then put the key back, and then nobody knowing who took the key. In a hospital, an iris scanner will be the most suitable because it works without contact, is accurate even when staff wear gloves or masks, and maintains hygiene while controlling access efficiently. Fingerprint scanners would be less practical, and facial recognition could be affected by masks, making iris scanning the best choice for this scenario. Again, what we've explained before when we're looking at biometrics, the higher the security required or the more controlled access required, then you're going to expect the company or the establishment to spend more money on this. It will normally take more time and it will cost more money as well, but way more secure. And look how I modified this question to be in a hospital, because this is going to make you understand why the scenario is important. You have to visualize the scenario. Don't ignore the scenario and just jump to this second line here. Compare different biometric systems. Really understand this is where most students lose marks. They answer perfectly good answers, but for a totally different question, and lose all the marks. Okay, that was recognition systems. Quite a few questions I went over because there were so many different items involved in recognition systems, from biometrics, from OMR, OCR, and so many different variations of uses of RFID. I thought I'd put a little bit more effort to put a richer choice of questions with different scenarios so you can really understand how to read the question and understand what you have to answer, and then use these particular questions and answers as revision notes. So all the material I've used here, you can download from the description in this video as a PDF form. You can also find the links to the other units of the chapter of ICT Applications. If you've liked what you've seen, you've learned something new, you know the drill, guys. Make sure you like, make sure you subscribe. Take care. I'll see you again in the next video. Bye-bye.